Hi there. This video will be about how to find the surface area and the volume of a cylinder. And before we talk about what a cylinder looks like, although I'm quickly sketching one for you right now, my drawings are not great. Let's talk about what surface area is, okay? Surface area is the amount of material needed to cover a three-dimensional object, kind of like an orange peel around an orange. How much orange peel is needed to go around an orange? That would be the surface area of the orange. Okay, and whenever you find surface area, your answer will always be squared. So if it's centimeters, you'll write the answer like that. Okay? Or square feet, or square inches, or square meters. You'll just have that little 2 up there at some point. Volume, instead of it being the outside area, it's the amount of space inside a three-dimensional object. So it's like the part of the orange that you actually eat, the juicy part of the orange under the peel. That is the volume, okay? And it's measured in units cubed. So if you're talking about centimeters, it would look like this. Okay, so whenever you see a little 3 like this after the units, could be inches, feet, meters, centimeters, etc. If you see a little 3 like that, that means they're talking about volume. If you see a little squared or a little 2, you know that they are talking about the surface area. Okay, this is what a cylinder looks like. It's a little better than the drawing I had. A cylinder is related to a circle, and there is a radius that comes from the middle all the way to the outside. Here is our height right here. And if you were to flatten out a cylinder, kind of like a cardboard box, you would end up having a shape that looks something like this. In math, some teachers call these things nets, okay? It's the flattened out form of a cylinder, okay? Don't worry about the numbers you see here. It's just today, we're just doing this so that if we were talking about surface area, we're really talking about the area of 2 circles and a rectangle. That would be the surface area. If we were talking about the volume of this cylinder, we'd be talking about how much water would fill up this cylinder. And the way to do that with a formula is that we would take the area of this base down here. Remember the area formula for a circle. Make sure you've seen that video first. Okay, the area formula for a circle is pi r squared. And then all you do is you take the area of that thing we call the base and multiply it by the height. It's like stacking a whole bunch of CDs or circles on top of one another to become whatever height is needed. Okay, so you find the area of the base and multiply it by the height. Speaking of which, let's go look at the formulas. Okay, so back to the surface area that we looked at earlier. There's 2 circles, one here and one here. I don't know if I should even dare try to trace them. Oh man, it's very bad. Okay, there's our 2 circles. That's why it says 2 times the area of the base. Well, the base and the height are actually identical. They're both circles. Okay, so it's 2 times that area plus the area of this thing right here, which above is called, it says lateral there, but in this case it is a rectangle, as you can see. So the actual formula for the surface area of a cylinder is this right here. 2 pi r squared, because pi r squared is the area of a circle and there's 2 of them, plus 2 times pi times r times h. Well, over here is our rectangle, and we could spend some time showing you how the radius and the height can be used. Basically, the circumference of this circle right here is really this distance right here. So 2 pi r is this distance right here, and then the height is this right here. Don't let that confuse you too much. For now, just here's our formula that we use. And for volume, we're going to use this formula right here. I'm going to put a box around this volume formula right here. It's pi r squared times h, which is actually simpler. All we do is think of it as a circle, the area of a circle multiplied by the height, just like I was saying before. Now let's practice this, and we'll flip back to this page when we need this formula or when we need this formula. Okay, let's look at the first question. What is the volume and surface area of this cylinder? Let's start with volume since it's a shorter formula. Let's look back here. What's the volume formula? There it is. It's pi r squared h. Okay, we don't know the volume of this thing, but what we do know is we do know the radius and we do know the height. In this question, remember 3.14 is pi, and I'm going to put a time symbol there. I probably am not, actually no, I'm going to remove the time symbol. Let's put it in brackets. What is the radius? Be really careful, people. When you see a question like this, sometimes it's easy to make mistakes. This 16 right here is not the radius. It's very close to the radius. It's actually the diameter, the distance across. The radius is the distance from the middle all the way to the outside. So what would that be? It's half of the diameter. I'll give you that hint. Okay. Without further ado, it would be 8 centimeters. The radius would be 8 centimeters. Don't forget the squared, which means we're going to times 8 by itself. And then we also have to multiply by the height, which is 22. Okay, at this point we can take a calculator and multiply this all out. So let's do that. It would be, if you had a regular calculator like this, you'd go 3.14 times 8. And there's a squared button right there, so you could hit that, or you could go times 8 again. I'll just do it twice, just to show you. And then multiply also by 22. Okay, so up above here on the calculator, you can see what I just did, and here we can see what the answer is. Okay, 4421. And let's round it off to 1 decimal place, so 4,421.1. And that is the volume, and it's centimeters, so we're going to write it like this. Cubed. Remember, we put cubed for volume. All right, we are done the volume. Now let's do the surface area. Okay, surface area. What is the surface area of a cylinder? Let's look at the formula. 2 pi r squared, so let's write that down. 2 pi r squared, I'm afraid I'm going to run out of room, plus 2 pi r h. 2 pi r h. Am I going to run out of room? I'm going to have to just put the surface area part right there so that we have a little more room. 2 times 3.14, yikes, times the radius. Now the radius is 8, if you recall. Squared. Plus 2. I'm going to not write 3.14 because I'm going to run out of room. Times the radius again, in brackets, times the height, which is 22. It's just a lot of writing here, because really what we're going to do is calculate this. I'm actually going to calculate it in 2 steps. I'm going to take a calculator, figure out this part, write it down, then figure out this part and write it down. Then I will add the 2 together. Okay? So let's do that right now. 2 times 3.14 times 8 and times 8 again because it's squared. Okay. I'm going to 401.92 plus, let's do the other side, 2 times 3.14 times 8 times 22, 1,105.28. 1,105.28. Now all we have to do is add these 2 together and we will have our surface area. Surface area is more complicated to do than doing the area, as you can see. It's a longer formula. I'm just adding the 2 together right now, and the final answer I got is 1507.2. Be careful of the units. It's centimeters. Don't leave it as centimeters, otherwise that would be a straight line. We need to put a little 2 here to symbolize that we're talking about surface area. This would be the final answer for the surface area, and over here is the final answer for the volume. Okay, so there's volume and surface area. Here we have one more question, and I believe this is the last question from our list of questions today. Sometimes there's word problems like this. It says 3 golf balls are packed tightly into a cylindrical container. If one ball has a radius of 2.1 centimeters, so a radius means the distance from here, the inside of the ball, all the way to the outside, and we'll assume it touches the packaging. It comes to the end and touches this plastic packaging. That's 2.1 centimeters. Okay? How much material is needed to make this container? So when you do a question like this, ask yourself, are they asking for the volume in this situation, or are they asking for the surface area? Well, unfortunately, they're asking for the surface area because they're asking about the material, this material here, and it's in a cylindrical form. So we need the surface area formula. Now, if you don't have it memorized, just go back a page. Okay? I wonder if we could even just copy and paste it. No, we can't. We're going to write it down. 2 pi r squared. At least we have lots of room here. Plus 2 pi RH. Okay, we have lots of room now. So 2, and I'm just going to write pi there because we know it's 3.14. The radius is 2.1 squared plus 2 pi. Again, we have 2.1 centimeters. And oh wow, look at this part, people. We need to know the height of this container. Well, we know that the distance between the middle of a ball and down here is 2.1, right? So would you agree that it's 2.1, and if we multiply that number by 1, 2, 3, 4, 5, 6. If we multiply that by 6, that should give us the height. Okay, so let's try that. 2.1 times 6 is 12.6. So this height, 12.6, is our height from up here all the way down to here. 12.6. Wow. Okay. Once again, let's multiply it. I'm going to do it in 2 parts. 2 times 3.14. Feel free to do this on your calculator too. Times 2.1 times 2.1. And we get, I'm going to round it off because it's a lot of decimals here. Let's round it off to 2 decimals. 27.69. Sorry for the mess. 27.69 plus, let's move the calculator over so we can see, 2 times 3.14 times 2.1 times 12.6. And let's round it off to 2 decimals again, 166.17. Okay, and the final answer, all we have to do is add these two together. 27.69 plus 166.17, and we're left with 193.86. 193.86. Don't leave your answer just like that, people. Make sure you put units, okay? They were talking about centimeters here, so write centimeters. And we are talking about surface area here. So would we put a 2 here, or would we put a 3 here? If you're saying 2, you are correct, because we are talking about surface area. There are all kinds of questions teachers can ask you with regards to questions like this. They could say, oh, how much space is in this container right here? What would be the volume of this container? And you would be able to figure that out. However, in this case, they just asked the surface area. They could have asked the volume, and you would have been able to find it. But for now, that is all. And I hope you are okay with this. Have a great day. Take care.